So when you're looking at this next question, this is your initial circuit here. So you've got your RL motor load here taking your 50 amps. You've got your power supply here, 230 volts, 50 hertz. And it tells you that the power factor of the RL branch is 0.6 lagging. So lagging always just means an inductive circuit. So again, from that, you can get the phase angle of the RL branch. We're doing the inverse cos of that 0.6. And that gets you 53.13 degrees. So now you can mark in your IRL on your phasor diagram. 53.13, round about there. I've decided my scale is going to be 1 centimetre equals 10 amps. That's my IRL. I'll mark in my VS as well. That goes along my reference axis. That's what I'm comparing everything to. It's in there. So that's what you've got so far. Now this time, you're not correcting your power factor to unity. You're correcting your power factor to 0.9 lagging. So you want to come up, but you don't want to come up the whole way. So your theta for your circuit, or rather, your power factor for your circuit, is to be increased from 0.6 to 0.9 lagging. So if it's lagging, it's still on the same side of that axis. So you want to come up before here, not after here. If it was leading, you'd be moving across that axis. So if it's 0.9 lagging, then the angle that associates with that, the same way as you did it up here, is 25.84 degrees. So it's 25.84 degrees in here. So that'll be your IS. That's your corrected IS. So you're trying to work out what value of capacitor will give you this wee bit here. Which would be here. So that's what you're trying to work out. So when you look at this phasor diagram, what you should notice is that you've really got a big triangle that's got an angle of 53.13 degrees, and within that you've got a smaller triangle (25.84 degrees). So using that, you should be able to use your SOHCAHTOA to get the value of IC. I'll give you a minute. So as you look at your triangles, you've got that big triangle, which is this triangle here, and then you've got this small triangle inside it, which is this triangle here. And to get IC, you're looking for the difference between that opposite and that opposite. That's what IC is. So the first thing you have to do in this triangle, you have to work out the opposite. Using SO, and you have to work out the adjacent. Using cos, or the Ka. So you'd work out those two first. Then once you've got the adjacent in this one, because one sits inside the other, when you've got that value there, that will be the same as that value there. They're both the same size. So when you work out that, you work out that. Then in this triangle, you have an adjacent. You won't have a hypotenuse, but you can use the adjacent, the angle, to work out the opposite. Yeah?